Good morning, afternoon, evening, whatever time you happen to be watching this. Your notes for this session, if you look at the top of your page, is for spheres. Yes, that's how you say that word right there. It's not spears. Think of the word phone. PH makes the F sound. So spheres, spheres. Spheres you see lots of places. Volleyballs, baseballs, softballs, okay? All different kinds of shapes that are used for sports and stuff like that are, here's a softball with Mr. Dudley's name on it. That's just who made the softball. Baseballs, basketballs, volleyballs, all those are types of spheres. Now, there's formulas that we use for solving the volume of a sphere. So what I want you to think of for solving the volume of a sphere is think of a bowling ball, okay? Bowling balls are heavy. They have the same, that same material that's on the outside goes all the way through it. So when you think about volume, think of a bowling ball. And we're going to figure out how much space is on the inside of those. Now, a sphere is also referred to a lot of the time as the perfect shape, because basically what it is from the very center of it, which in this case, this point right here, and in every direction, the same exact distance, the radius, obviously, the radius is how it's made up. So from the very exact middle of it, in every direction, you'd hit the outside of it, and that's why it's sometimes called the perfect shape. Now, you've also heard of spheres when you've been in science, and you've heard of what's called a hemisphere, right? If this was the globe, you'd be looking at the northern hemisphere. That means hemisphere means half of a sphere. So northern hemisphere, southern hemisphere. Of course, in the middle, it's a circle. We got the middle here, and we've got radius in every direction. It's just that instead of just going out to the outsides of the circle, it also goes all the way through it in every direction too. So it's a good way to remember, when you're dealing with a sphere. Now, the formula that we have for a sphere, we didn't write the whole thing on here because we wanted you to see it. It's pi radius cubed. I'm going to zoom in so you can see that a little better. Okay, but you look on your formula chart, it says 4/3, so please fill that in. It's a very, very weird formula to use, but our knowledge of formulas and how to work them should help us get through this. The other weird part about it is this number here is cubed, okay? So you're basically taking the radius and you're cubing it, which means times itself 3 times, okay? So that's why the formula looks like that. That's what it says. So 4/3 pi r cubed. So let's go to our notes side here for our list of stuff we're going to be doing here. We've got volume, which is what we're solving for. Again, when we get to surface area, these sheets are going to look the same, except we're just going to be doing surface area. The name of the shape is a sphere. Again, not a spear. The formula, volume equals 4/3 pi radius cubed. 4/3 pi radius cubed. Now, we'll talk about this in a minute, but to find 4/3 of something, if we think about it, if you had to find 1/3 of something. You would divide by 3, right? Well, we're still going to do that same thing, but now we're finding 4/3, which means we're going to divide by 3 and then multiply that times 4. Okay? So, radius, in this case, it's right there. It says that it's 2, so we're going to write down that the radius is 2. So now we're going to come over here. We're going to write our formula out. 4/3 pi radius cubed. Well, if we look at the formula, there's only one thing we don't know that it even gives us. It's the radius. So really all we got to do is take that number, put it in the formula, and then solve it out. So 4/3 pi times 2 to the 3rd power. 4/3 pi times 2 to the 3rd power. Now, if we're multiplying times pi, I'm going to make this as easy as I can. If this was 4/3 is a fraction, right? Well, I'm going to multiply. I'm just going to use 3 for pi. Okay, see what I did? Just use 3 for pi, put it over 1, and that answer's going to be times 2 to the 3rd power. So 2 times 2 times 2, which is 8. Okay? Now, if you're ever doing a test or a problem that requires you to use pi, then the only difference between what I just did and what you would do is you would actually put 3.14 right here. Okay? When we use 3, this formula becomes very easy because we're doing 4 times 3 times 8 on the top, right? 4 times 3 times 8. And on the bottom, we're just doing 3 times 1, which is 3. Okay? So if you're at that point, we can make this even easier because the 3 here and the 3 on the bottom cancel each other out because 3 divided by 3 is 1. So that gets rid of the 3 on the top, gets rid of the 3 on the bottom. So really all you're going to do is 4 times 8 and you get 32. Now, these problems could possibly be harder if they give you pi to use 3.14. Okay, so I'm going to show you that also, so you see what the process would be. It'd be 4/3 times pi. I'm going to put that over 1. And then again, times what we got was 8. Okay, so doing the math, doing all the actual numbers might be a little difficult, but again, you're in 8th grade and you should be able to do 4 times 3.14 times 8. But to make it a little easier, instead of doing 4 times 3.14 times 8, the order you do this does not matter. Okay, so you can do 4 times 8 first, which is 32. Again, I just multiplied these two numbers together first. And then that times 3.14. And then all that divided by 3. That's going to make your problem a little bit quicker and a little bit easier. Okay, now to save time on this, I'm not going to actually do out the math. I'm actually going to just write down what the answer is to this so that it makes it a little easier for you. So 32 times 3.14 is 100.48. It's over here, sorry. And then dividing that by 3 will give me an answer pretty close to what we had before. It's 33.49. I'm just going to round that to 33.5. Anytime you use pi for an answer, your number is going to be a little bit bigger if you actually use 3.14 instead of just using 3 for pi. And you can see that demonstrated right here. When we used 3 for pi, we got 32. When we used 3.14 for pi, we got 33.15. Okay, so that's the basic way we do this. And I would think that, this is going to be an easier way to do this, using 3 for pi, and then just knowing that if you got 4 answer choices, chances are the very next highest answer on the answer choice is going to be the one that's you're going to want to choose for the answer. Okay, let's do another one. Volume or surface area. Well, again, we're doing volume. The name of the shape is a sphere, spelled terribly. I'm going to start over. Sphere. The formula, 4/3 pi r cubed. The radius. Now, this one, if we look, they got that line going all the way through. Okay, so if this was our shape, if this was, our sphere, and we're going to imagine the whole thing, they're giving us the line that goes all the way across it. Okay, and we know that's diameter. But the formula asks for radius. So we're going to cut that number in half. Radius is going to be 5. And again, we're just going to come over here. We're going to just plug in the numbers and work out the formula. And to make this quick, I'm just going to use 3 for pi. And I'm not going to do it the other way this time. I'm just going to show you how quick and easy this is if you just use 3 for pi. So 4/3 times pi, written as 3. I'm making it a fraction by putting a 1 underneath it. The radius is 5. So I'm going to have to do 5 to the 3rd power. Okay? So I'm going to write this again. I'm doing my exponent first. 5 times 5 is 25. Times 5 again is 125. I'm going to cancel out these 3's. Okay? That's a rule. You can do that if you're dealing with a fraction that has multiplying on top and multiplying on bottom. I can easily cancel out those 2 3's. So now all I'm really doing is 125 times 4, which is 500. And again, since we're doing volume, this is in cubic inches. Now, just so you know, I'm not going to show all the math, but if I would have used 3.14 for pi, the actual amount of pi, fact, I probably wanted to do little squiggly equal signs right here. That means it's close to. If I actually did it exactly, I'd got an answer of 523.3. I'm pretty sure it was repeated. So the answer is not really that far off. I'm pretty close. Okay, so we're just trying to get you a basic idea of volume of spheres. We've probably never seen this before. But if you use 3 for pi, it cancels out that 3 on the bottom over here. It makes the problem really easy. I mean, I've actually shown it where you just write it like this. The 3 cancels out and pi cancels out. So all you really have left is 4 times radius cubed. Okay, so either one would work. They both work pretty easily. Okay, there are your notes, and we will handle more volume of sphere problems when you get to class. All right, we'll see you later.